Welcome back to the final episode of this series on how plants convert sunlight into biomass. The radiation use efficiency measures the bulk photosynthesis efficiency. It is computed as the ratio of the radiation intercepted by the green part of the vegetation and the biomass accumulated during a given time period. The radiation use efficiency that converts the intercepted radiation energy into the energy stored into biochemicals is only 3% to 6%. This is much lower than the efficiency of solar panels that can reach up to 20%. This efficiency is often expressed in terms of mass of biomass produced per unit intercepted radiation and is around 1 gram of biomass per megajoule of intercepted radiation up to 3 grams per megajoule. Estimating the radiation use efficiency requires three major inputs, as seen previously: the amount of radiation incoming above the vegetation as derived from specific sensor or from data provided by synoptic values of the global incoming radiation or estimated from satellite observations. Second, the radiation interception efficiency as monitored by our high-throughput system from two RGB cameras viewing from nadir and 45-degree inclination. And third, the biomass accumulated by the vegetation during the period. This is the main limiting input since there is not yet reliable methods to estimate directly the total above-ground biomass from high-throughput measurements. Biomass is currently measured by destructive sampling, collecting samples of vegetation and weighing the corresponding dry matter. Several attempts have been proposed to build empirical relationships with structural characteristics that can be derived from high-throughput measurements. This includes allometric relationships with plant height by volume, the volume of stems per unit area, or the leafer index. However, the robustness of the relationships has not yet been demonstrated when applying them across contrasted genotypes. In fact, crops with the same biomass may correspond to different structure, which may include biases in the estimation of the biomass and thus biases in the estimation of the radiation use efficiency. More work is therefore needed to get more robust and accurate estimates of the above-ground biomass from high-throughput measurements. I hope that I have illuminated the process of how plants convert sunlight into biomass. If you want to learn more, my colleagues at IFEN are always excited to talk about high-throughput applications.